All right, guys. Yeah, I was saying, does anyone have like any question about the homeworks or the review sheet or anything in the material?
Okay, hold on.
The review 1B. Yes, Yan. Yeah, sure. 1B in the review. Okay. Okay. Well, so let's do. Well, then we can start with the problem 1 in the review sheet then. Natalie. Yes, I think I mean yeah, I think we have time. I'm gonna try my best. Yes, I'm gonna try my best. So like we can like okay 6A and 6B. All right, 6A and 6B. All right. Okay, I'm gonna try to cover. I mean to go over all the problems and all right. So let's start with the problem 1 then. Eliani, you said the 1B, right? If I'm not mistaken. 1B, okay. So B. All right, guys. So in this 1B, so we have this minus x squared minus y to the power 9 plus 4 equal to 1. Okay, so you want to determine whether y is a function of x, right? So there are always like 2 steps, guys. First, you try to solve for y. Solve for y. Okay. You solve for y. So like here, minus. Now, Candice, I didn't take the attendance because today is just a review and the test. So now I'm not taking attendance. I'm gonna give you a break today, guys.
That's
Yes.
a G on top of the Y.
No, that's a 9.
Okay,
Sorry,
no.
my bad. That's not a G. That's my 9. It's power 9 in the problem. Sorry, there's something in the chat. I missed it. Let's see. No, you don't have to send me the review sheet. No, Elizabeth. No. You don't have to turn in the review sheet. No. So yeah, 9 plus 4 equal to 1. So I'm gonna try to solve for y. So so I'm gonna add plus x squared both sides, right? So this is now negative y to the power 9 plus 4 equal to 1 plus x squared. All right, and then I'm gonna subtract 4. So this is now, so this is negative y to the power 9. And on the right side, it's 1 minus 4, which is negative 3, and plus x squared. All right, so I want to solve for y. There's this minus. This minus actually is bothering me, and there's this power 9. So let's get rid of the minus first. Okay, so I'm gonna divide or multiply by negative 1. Okay, so I'm gonna multiply by negative 1, and so I have to do the same, of course, on the other side. So now it's y to the power 9, right? Because this negative would be a plus, and on the other side, so minus 3 would be plus 3 because I multiplied by negative 1, and plus x squared is going to be minus x squared, right? And then I'm going to apply the 9th root. So 9th root both sides. 9th root. And because the power here is 9, so there's no plus or minus. Okay, because 9 is odd. So it's now it's just y on the left, and on the right side it's a 9th root of 3 minus x squared. Okay, we don't have it simplify the right side anyway. So it's 9th root of the 3 minus x squared, and okay, so I got my y. Now in the second step, I have to check that for each input x, we have exactly one output. And here, because there's no plus or minus, so the answer would be, well, then this is a y is going to be a function of x. So for each input x, so because there's no plus or minus, because there's no plus or minus, then for each x, for each input x, for each input x, there is exactly one output. Y, so y is a function of x. So it's a function of one output y. So y is a function of x.
On the test, do we
Yes.
have to put all that, or can I just put?
What do you
it's a
mean by all
function?
that?
Well,
First
the
step, yes.
explanation.
No, the explanation is
step
for you
two.
guys. No, it's just for,
Okay.
it's for you guys. So in the test, you can just say there's no plus or minus, then it's y is a function of x.
Okay.
I'm just trying to explain to you guys why.
Wait, Professor, you said there is a plus or minus?
No, there is no. I said there is. Oh, there is no. Sorry. There's no. Of course, there's no.
Okay, and also, when you multiply -1 by both sides, how is it? Wait, did you factor a negative from 3 plus x?
Yes. So no, I didn't factor really. I just I multiplied each term by a -1. So it's like this -3 multiplied by -1, and then the plus x squared multiplied by the -1. So each term is multiplied by a -1. Does it make sense?
Okay, wait. All right, so
Because you have to multiply the whole thing by -1. So here you see I multiplied the left side by -1, so I have to multiply the whole right side by -1. Each expression or each term in the right side has to be multiplied by -1.
okay, all right.
So the -3 has to be multiplied by -1, and the same for the x squared, the plus x
Right.
squared.
Okay, all right, and then when will be the time where you have to do that?
Oh, that's because I had the I had the minus here, minus y to the power 9, right? So I had to get rid of this minus. That's why I multiplied by -1
Okay.
to get rid of this minus in front of the y to the power 9. I had this minus.
Yeah, you see what I did was yeah, I did divide y. Yeah, I put a negative y over -1, and then I tried doing that to the other side.
Okay.
Is that the same
You can also divide. You're right. I mean, you can also
Oh,
divide
is
by
that the same
-1.
thing? No.
Yeah, same thing. It's the same thing.
Oh, okay. Oh,
You can either, I mean, you can multiply or divide by -1. Both are correct. But when you multiply by -1, it means you have to multiply the whole thing by -1. So each expression or each term is divided by -1. So it's like -3 divided by -1, the plus x squared divided by -1, right? So when you divide by -1, of course, you change the. Excuse me.
Sorry about that.
Yeah, I'm just saying when you divide by -1, of course you have to change the sign. You change the sign because you are dividing by negative. You divide by negative, so you change the sign. So -3 becomes +3, and the plus x squared becomes minus x squared. Right. Is there any other question, guys, about this? As I said in the test, you don't have to write this whole thing here. Like, just say, well, there's no plus or minus, then it's a function. Or if there's a plus or minus, there's a plus or minus, then it's not a function, right? And that's it. I think someone asked about the 1D, the graph. So for the graph, guys, so we want to determine if the graph is a function or not. All you have to do is so this is a problem 1D, right? So you have a graph, so and you want to determine whether the graph is a function or not. All you have to do, guys, is to use the vertical line test. Okay, so here's the graph. It's like, looks like this, something like this here.
It would always just intercept in one point if.
Yeah, yeah, absolutely. So all you have to do, guys, just use the vertical line test. Vertical line test to determine whether the graph is a function. Yes, Ariane, yes. Whether the graph is a function. So like here, well, if you use the vertical line test, of course, if you take any vertical line is going to intersect the graph at exactly 1 point, no more than 1 point. Well, here it's a 1 point, but here, of course, there's no intersection, and that's okay. It's so every vertical line has to intersect the graph at no more than 1. So it could be 0 or it could be 1 point, but no more than 1. So if it's 1, it's okay. If there's no intersection, it's okay. Here we have again 1 point, 1 intersection, etc., etc. So all the horizontal lines are going to intersect the graph at no more than 1 point. So then this graph is a function. So it is a function. Right. So let me just write it down again here. So each vertical line has to intersect the graph at no more than 1 point. No more than 1 point. Okay. Any question about this vertical line test? Okay, so now let's move to the next problem, number 2. I think, Eliani, you said for number 2, you want to do the D. No, sorry, the F. But anyway, I mean, we can do very quickly the A, B, C, D, etc. So for example, so here number 2, we have 2 functions. This x minus 2 over x minus 5. And you have this square root of x plus 3, right? So first, we want to find the domain of f. So for f, so domain of f, well, we do have a division in f, right? There's a division, so you have to solve. So division. So you solve the denominator equal to 0. So then that will be x minus 5 equal to 0. And so x would be equal to 5. So then the answer for A, so we have to exclude this 5, this answer. Here we have to exclude it, okay, from the domain. So you have your number line. And what we are saying is that, so x could be any real number except 5. So it's going to be like, so negative infinity, 5 excluded, union 5 excluded, positive infinity. Okay. Please, guys, feel free to interrupt me. I mean, if you have any question, right? For B, that's the square root. So that's the g of x. So here in the g of x, we have square root, right? So we have to solve what's under the square root larger or equal to 0. So solve this x plus 3 larger or equal to 0. Just subtract phi from both sides. So your x is just larger or equal to negative phi. So on the number line, x would be on the right side of negative phi. So the answer domain of G would be like, you start from negative phi, x is larger than negative phi. So you go from negative phi to positive infinity. Negative phi, of course, is included because x can be equal to negative phi. Now, for the domain of like f plus g, you just take the common domain. So like in C, so domain of f plus g domain of f plus g is the common domain. And there's, or the intersection domain. So here's your number line. So the domain of f. So I'm gonna need -3. I'm gonna need 5. So domain of f is any number except the, of course, this is negative infinity here, positive infinity. So domain of f is any number except the 5. So this is the domain of f. And domain of g is, it starts from -3 included, and it goes all the way to positive infinity, right? So it will be the intersection domain. So that will be so that will be the interval. So it starts at -3, right? And to a positive infinity, but we have to exclude the 5, right? So that's the interval, which is red and blue at the same time. So the answer here, so it's -3, 5 excluded, union 5 to positive infinity. That's the intersection domain, which is red and blue at the same time, right? It belongs to the domain of G and domain of F.
That would also be domain of f minus g and f of f multiplied by g. Right?
Yes, absolutely. Yeah, absolutely. So that will be the answer for the domain of F minus G. That's a good point. Okay, so so F plus G, F minus G, and F times G, they have the same domain.
And what about g over f divided by f?
Yeah, that's what I'm gonna do next. Have the same domain. So then there's F over G or G over F. So if you want to do, let's say G over F, I mean, it's up to you guys. So if you want to do, let's say G over F, so you have to exclude from the common domain, the values where F is 0. So exclude from the common domain the values of X where F is 0, where X is 0. Okay. If it was if it was like F over G, then you have to exclude the values where G is 0. So anyway, so for this G over F, so where F is 0, so that's the question now, where F is 0. Well, what's F? F is the X minus 2 over X minus 5. So when this is equal to 0, well, as I said, this is a fraction, and a fraction is going to be 0 if the top is 0. So we don't care about the denominator. So the fraction is 0, then the numerator is 0. So the X minus 2 is 0. So X is positive 2. Okay, so we have to exclude the positive 2 from the common domain, right? This is my common domain. So we have to exclude the positive 2. So then the answer here, the domain for G over F, it's -3. And then you stop at 2 because we have to exclude the 2. Excluded, you start again at 2. 2, 5, which is already excluded, right? The union 5 to positive infinity.
Wait, shouldn't the denominator?
No, because here, so the question was where F is 0. I'm not looking for the domain of F. I'm looking for the where F is 0. You see here, you exclude from the common domain the values where F is 0 because that's my denominator. So I have to exclude the values of X where the denominator is 0. So I'm not looking for the domain of F. So if I was looking for the domain of F, then yes, you're right. Then I would solve the denominator equal to 0. But I'm not looking for the domain of F here. I already got the domain of F in A, right? That's the first question, right?
So you're doing
But here,
G?
excuse me?
You're doing G?
Yeah, I'm doing
E.
E, sorry. I'm doing E. This is E. And for F over G, okay, F over G, then that will be the D. So for F over G, so we have to exclude from the common domain the values where G is 0. From yes, Eliani, I'm gonna exclude the negative phi, yeah, from the common domain. Common domain, the values where G is 0. So the question is now where, so where G of X is 0. So G of X is a square root of X plus C equal to 0, right? Then you square it, both sides. So then it's just X plus C now equal to 0. And so X would be negative phi. So we have to exclude this negative phi from the common domain. And again, the common domain, that was the answer in the C here, right? This is my common domain. I have to exclude the negative phi. So it's gonna be negative phi excluded now. So the answer here, so that'll be negative phi excluded, 5 excluded, and then 5 to positive phi.
But just to verify on the E, what you did is that you solved the numerator, and then you went by that. I mean, if it was equal to 0, then that's how you
Yes. So if you have a fraction, equal to 0, then all you have to do is to solve the numerator equal to 0. Yes.
All right. Got it.
So you can see, guys, the domain of F over G is different from the domain of G over F, right? It's kind of different. I mean, yeah, it's different. It's not the same answer. All right, and okay, last one, the F composed with G. This is also important for the E. Sorry, not the E, the F. Okay, now for F, the common domain. Sorry, not the common domain, but the F composed with G. Sorry, this is F composed with, so domain of F composed with G. Okay, so here we don't use the common domain. Okay, you forget about the common domain. So the step 1, you have to find or compute, simplify F of G of X. Compute and simplify. Compute and simplify if it's possible. I mean, sometimes it's not really possible to simplify. Okay, it depends. And simplify if possible F of G of X. Let me write it down here, if possible, because sometimes it's not. So F of G of X, right? The F of G of X. So that will be. So what's F of X? F of X is this X minus 2 over X minus 5. So you have to substitute this X with the G. So this X here in the numerator and the X in the denominator by G, right? This one here is G and this one here is G now. So that'll be like square root of X plus C, that's my G. And then there's this minus 2. So here's my minus 2 over, again, the square root of X plus C and minus 5. Okay, so that's F of G of X. Now, I got this. Well, the question now, is it possible really to simplify this? The answer is no, okay. So, well, then we have to find the domain of this. We have to find, so the step 2. So as you can see here, there's no simplification. No simplification. Right? Now, in the step 2, I have to find the domain of this thing. Step 2, find domain, okay, of the function in the step 1. And step 1. Right? Here's my function, right? This one here. Now, in this function, of course, we do have a division and we do have a square root, right? So first the division, then there's a division. And so we have to solve, there's a division. I'm trying to find the domain, right? So whenever you want to find domain and there is a division, then you solve the denominator equal to 0. So division, you solve denominator. Denominator 0. So that will be square root of x plus b minus
Quick question, Professor, I'm sorry.
Yes.
So if they're both not like a square root both, if it's just in the bottom, we only if there's only one side, we only find the domain of the denominator, right?
Yes. Yeah. The denominator. Yes. Equal to 0. Yes. Okay. So then there is a plus 5. Right, so this is square root of x plus b. As I said, guys, you cannot really change what's under the square root and unless you get rid of the square root. Okay, you cannot really touch what's under the square root. So this is equal to 5 now, right? And then you get rid of the square root. You square both sides, right? And then, so once you square, so it's now x plus c equal to 25. And then, of course, just subtract 3 now. So your x is 22. All right, so the x equal to 22, this, we have to exclude this from the domain. So excluded. Okay, we have to exclude it from the domain. That's where the denominator is 0. So we have to exclude it from the domain. Okay, now, so we said there's this division and there is also a square root, as you can see, right? There's this square root here of x plus c, and that's actually square root of x plus c, that's my function g, right? So we have to, so there is a square root, so we have to solve, so what's under the square root? Under the square root, we have x plus c, right? So we have to solve this x plus c larger or equal to 0. Okay, because we are not allowed to have negative numbers under the square root. All right, so, well, here, subtract 3. So this is x larger or equal to negative 3. Okay. So what we are saying, guys, here is that, so your x must be larger or equal to negative 3. Okay, and then you have to exclude this 22. Right, so the 22 has to be excluded, but your x and x must be larger than negative 3. So like on your, so on your number line, this is negative 3, this is 22. So then, yeah, x is larger or equal to negative 3. So that would be this thing here. Okay, larger or equal to negative 3. But then we said we have to exclude the 22, right? So we exclude the 22.
I thought it was substituting x for the other function, wasn't it? To find the domain?
Yeah. I mean, we substitute x by the other function. That's what we did.
Okay. I just...
Here, right here. You see right here?
Yeah, I wasn't. I see.
Yes.
I see it now. All right.
Yeah. So we substitute x by g of x. Yeah, sure. You're right. And then, yeah, so anyway, so this x larger or equal to negative 3. So this is actually the domain of g, right? This is domain of g anyway. So this is domain of g. Domain of g. So anyway, so the answer here, guys, it's just so negative 3 included, 22 excluded, union with 22 positive infinity. So that's for F composed of G. Any question, guys? Okay. We have still time. So, okay, for number 3, let's move to the problem number 3. So if there are no questions about the domain, let's move to the number 3. Well, number 3, I think we have some almost the same problem like in the homework. But I think some of you had the trouble with the local minimum and also the range, I guess. But anyway, so let me just go over number 3 very quickly. So problem 3. So we have this graph. So here, this is like -4, and that's why actually I put this problem in the review sheet. It's for the homework.
Do we have to do the line and then graph it like that? Like
No.
Domain. We can use for
No.
the domain.
You don't have to graph any. I mean, no, you don't have to graph again the function f. No, just put your answer. I mean, of course, you have to justify your answer if it's required, but otherwise, no, you don't have to graph again f. Yeah, so there's this positive one right here. Let's see, this is -2 here and here at P. So -4. This is negative. Okay, anyway, so here's the graph. So the graph looks like something like this. All right, that's the f of x. So, and here, this is supposed to be 4. Okay. So for the range, guys, how do we find the range of a graph? So for the range, use horizontal line. So for the range, use horizontal lines from, you start from the bottom and you go to the top. Lines. So from the bottom to the top. Okay. For domain, you would use, if there was a question about the domain, then you would use vertical lines. And whenever, of course, there is intersection, use vertical lines. And of course, from left to right. So this is, of course, negative infinity. This is positive infinity. So from left to right. Anyway, so like here for the range, what would be the range? Well, so for the range, you start from the bottom with the horizontal lines, right? So we do have intersection here because again, the arrow means that the function, the graph continues, right? It doesn't stop. So you have intersection here when you are at negative infinity. And so you move to the top, there's still intersection. So you are still in the range, we are still in the range. But then, so the last intersection would be at the level or at the height y equals to 4, right? This is so the last point where we have intersection with the graph is at the level y equals to 4, right? So if you go from the bottom to the top, that's like negative infinity to 4. So the answer here would be like negative infinity 4, and 4 is included because we do have intersection when you are at 4, right? We do have intersection here. All right. The x-intercept, guys, is just the intersection of the graph with the x-axis. So the x-axis is this one here, the horizontal axis. That's the x-axis, right? So where do we have intersection with the graph? So the x-axis intersect the graph at this point here and this point. Okay, that's where we have intersection between the graph and the x-axis. So that's -4 and +4. Yeah, Lord, very good. So x-intercepts, it's just, so -4, and you put comma 0 because the y is always 0, and +4, comma 0. That's the point. 4, 0. Right. Now the y-intercept, it's just the intersection of the graph with the y-axis. So the y-axis is the vertical axis. This one here, this is the y-axis, right? The vertical axis. Now, where my graph intersect the y-axis? Well, it's intersect the graph the y-axis at 1, right? So the y-intercept here, y is 1, but you need to put 0 with comma before 1. Okay, so that's 0, 1. Local maximum, guys. Well, there are 2 local maximums actually. There is a local maximum here. As you can see, this is actually a global maximum. It's not just a local. This is a global maximum. Right? And there's another local maximum, which is this point here, because this point we have like a sort of a parabola, right? So this vertex, that will be your local maximum, which is x equal to 3, right? So we do have a local maximum at this point here. This is a local max. So to answer the question, we do have local maximum at x equal to -2, right? And x equal to +3. For local minimum, I know most of you guys in the homework said like local minimum would be negative infinity. Negative infinity or positive infinity, they are never local minimum or local maximum, because they are not numbers. So in this graph, actually there is a local minimum, but it's not at negative infinity, but it's actually at +1 here. You see here at this point here, there's like a parabola, and so there is a local minimum at x equal to 0 because the corresponding x is 0. And so there's a local minimum at x equal to 0. What else?
We got f of 4.
Oh yeah. Okay. F of f. Yeah. Let's do the f of f. Yes, Lisbeth. Sorry.
So how you write the local minimum?
The answer. So
Yes.
local minimum. So it's at x. So there's a local minimum at x equal to 0. Okay. All right. So we said, guys, f composed with f. Max, Natalie, it's so we're gonna have a local max at, actually, as I said, there are 2 local maximums. One at x equal to -2, so at x equal to -2, and x equal to +3. Yeah, so now what about the f composed with f of 4? F of -2, that's equal to 4, right? Now, what about f? Sure. What about f composed with f of 4? So this is by definition, guys. So we have first f, and then parentheses, we have another f of 4. Okay. So first, we have to evaluate what's inside the parentheses. So inside the parentheses, we have this f of 4.
It's equal to 2.
Which is equal to 2. Sorry, no. F of 4, it's actually 0.
Oh yeah, you're right, because it's not a classy.
Yeah, it's 0. So this is actually equal. There's an f outside the parentheses, right? There's this f outside the parentheses. You have your parentheses. Now inside the parentheses, that's f of 4, which is, we said it's 0. Okay, and now I have to evaluate. This is not f times 0. This is f of 0, and f of 0, it's actually +1. So the answer here would be +1.
I see.
Okay. Okay, probably I can move to the problem number 4. I mean, unless there's another question about the.
Yeah, I think that's fine. That's clear.
Yeah. Okay, perfect. So number 4, yeah, the even, odd, or neither. Okay, so this is, so for problem number 4, so just to remind you guys, so even, this is when f of minus x is equal to f of x, and odd, this is when f of minus x is equal to minus f of x. Okay, so for example, first example, it's x cubed minus x. So like always in the first step, you compute f of minus x. So step 1, you need to find f of minus x. So what's f of minus x? Well, f of x is x cubed minus x, right? So what we have to do is we have to substitute this x, the x with minus x, x with minus x. So this x becomes minus x, and this x here becomes minus x. I'm gonna just use circles here. So the circles is like they are like parentheses. So x becomes minus x. So here inside the parentheses I have minus x. Okay, and inside here the circle or the parentheses I have another minus x. Now, what do we have outside the circles or outside the parentheses? So outside the parentheses I have a cube and I have this minus, right? All right, so this is, so f of minus x is actually, so again, think of the circle as a parenthesis. So this is like minus x parentheses, and then there is a cube outside. And then there's minus, and then there's parentheses minus x. I think it's a really good idea to use the circle and the parentheses, guys, because otherwise it's very easy to get confused with a minus sign. I mean, well, that's my advice for you. Of course, it's up to you, but that's my advice. Use the circles. If you're struggling with a minus, like this is a substitution here, x with minus x, use just the circle as I do, right? And think of the circle as like parentheses. Okay, now you have like minus x cubed. Okay, and the thing is, because this is a odd power, then it's gonna be so this is like minus x, minus x, minus x. So it's odd, yes. So the answer, so negative times negative times negative, that's so negative times negative, this is positive, but then positive times negative, it's negative. So the answer here, so the sign is going to be negative. And how many x? Well, x times x times x, that's x cubed. So it's minus x cubed.
That'd be odd.
Well, we are not done yet, because you're right, that would be odd, but we are not done because there is another. I didn't finish with the f of minus x. So that would be minus x cubed. And then there's this minus minus x, right? This minus minus would be a plus. So it's minus x cubed plus x. Okay, this is f of minus x. All right. Now, in order to be even, f of minus x must be equal to f of x. And if you check f of x, let me just write down here again, f of x. So what's f of x? F of x is x cubed minus x. Okay, so f of minus x and f of x, they are not the same, they are not equal. So then this function is not even, obviously, right? This is not, so then f of x is not even. Not even. Okay, because by definition, in order to be even, f of minus x must be equal to f of x, but they are different. Right? Now, I have to check if it's odd. To check if it's odd, I have to compare f of minus x to minus f of x. All right, so let me write it down again. F of minus x. What's my f of minus x? Well, we said it's minus x. Yeah, minus x cubed. No, it's not minus 2x. Minus x cubed plus x. They don't simplify. You cannot they have different powers, right? So minus x cubed plus x. That's f of minus x, and I have to compare it to minus f of x. So minus f of x. What's minus f of x? Well, it's minus, and then for the f of x, guys, you have to use parentheses. So this is like minus parentheses f of x. So minus parentheses f of x, which is, you know, x cubed minus x. That's my f of x. So if you multiply by this minus, so we think of this minus like -1, right? This minus is like -1 times, okay? And so it's going to be like -1 times x cubed. So that's like negative x cubed. And -1 times minus x, that will be plus x. So this, again, this minus in front of f, you think of it as like a -1. Okay. Now, as you can see, if you compare now f of minus x to minus f of x, well, they are equal, right? They're the same thing here. So these two things here are equal, are the same. So then f of x is odd. Because f of minus x is equal to minus f of x. Okay. So the first step, you find f of minus x. In the second step, guys, you're supposed to compare your f of minus x to the f of x, the original function, right? The initial function. They are not equal. Like here, they are not equal, so it's not even. And then you have to compare it to minus f of x, right? And well, in this example, they are equal, so then f is odd. All right, so guys, in the test, you have to justify the answer. If you just write like, well, my function f is even or odd, you won't get any credit. Okay, you have to justify your answer. This is really important for this special. I mean, especially for this problem, you have to you have to explain, justify your answer. Do you want me to do another f, or I can probably move to the next problem? Okay, so I'm gonna move to the next problem because it's the same. Yeah, it's always the same thing here. The next problem, this is what we did on Tuesday, right? This is the quadratic functions, right? So I'm gonna just remind you guys. So problem 5. So we have this is f of x minus x squared plus 4x minus 2. So this is a quadratic function, right? Because the highest power of x is 2. So it's a quadratic function. Now for a, you have to find the vertex. So how do you find the vertex? Well, you have to find minus b over 2a. Okay, so like here, a is -1, b would be 4, and the c, of course, would be -2. So minus b over 2a, it's minus b is 4, and 2a is 2 times -1. So it's like minus, there's 4, and in the denominator, it's 2 times -1, it's -2. So this is -2, and negative, of course, over negative, it's positive. It's positive. So 4 over 2, that's positive 2. Okay. So that's the x coordinate. This is the x coordinate of the vertex. X coordinate of the vertex. Now we have to find the y coordinate, the output. So x, what I mean by x coordinate is the input. So the input is 2, the output. So to find the output, just evaluate f of, so we got 2, right? This is 2 here. I got 2, so I'm gonna compute f of 2. Okay. So f of 2, well, I just plug in 2 in the function f, so it's like minus square plus 4 times 2 minus 2, and the answer, so it's minus 2 squared, it's 4, so it's minus 4 plus 8 minus 2. Find the minimum and the maximum. Yeah, I mean, you mean the minus b over 2a? It's actually because, yeah, the minus b is over 2a. I mean, okay, so let me just say, you know, because your f of x, how we got such formula, it's because f of x is ax squared plus bx plus c, right? So if you know how to compute the derivative of this would be 2ax plus b, the derivative. Okay, so this is in Calc 1. And the derivative is 0, that's where you find your local maximum and local minimum when the derivative is 0. And derivative is 0 here, it means that x is minus b over 2a. So as you said, as you see, guys, to find the minimum and maximum, you have to know how to compute the derivative, and then you solve the derivative equal to 0. Okay, so again, this is in Calc 1. Derivative is in Calc 1. So that's how we got this minus b over 2a. It's not just like from guessing, it's really, it can be proved actually. Anyway. So minus 4 plus 8 minus 2, it's plus 4 minus 2, so it's positive 2. Okay, so we have the f of 2 is 2. So the answer, so my vertex is the point, so x is 2, the input x is 2, and the output y is also 2. All right, so the x is 2 and the y is also 2. It's just a coincidence that the x and y here are the same. Okay, it's just a coincidence. Right, so the x-intercept, the y-intercept, I guess you know how to do this, guys. I mean, the x-intercept, you just solve f of x equal to 0. You solve f of x equal to 0. I mean, so you solve this minus x squared, you know, plus 4x minus 2 equal to 0. So, I mean, if you don't know how to factorize, just use quadratic formula, right? So it's x, it's minus b. So it's minus 4 plus or minus square root of b squared. That's 16 minus 4 times a, which is negative 1, times c, which is negative 2, over 2a. So 2 times negative 1. So that's negative 4 plus or minus. So minus 1 minus 2, that's positive. So that's a 16 minus 8. 16 minus 8, that will be 8. So this is the square root of 8. And the square root of 8, I mean, it's not, I mean, 8 is not a perfect, it's not a perfect square. This is, so square root of 8 over negative 2. Okay. Actually, you can write square root of 8 like 2 times square root of 2. But anyway, so square root of 8, it's not a perfect square. I mean, it's not a whole number. Square root of 8. Well, of course, in the test, guys, I mean, I'm gonna make sure that you get a perfect square, that you have like a whole number. Yes, you can leave the answer like that. Yeah, you can leave it like that. I actually, well, yes, you can simplify the answer, because you can say, as I said, the square root of 8, it's 2 times square root of 2 over negative 2. So it's 2 times square root of 2, because you know square 8 is 4 times 2, right? And square root of 4, it's 2. So that's why I have 2 square root of 2, right? Anyway, so here you can just say, well, you can simplify if you want. I mean, you don't have to, but you see, guys, here I can divide by 2 the 4, and I can divide by 2 here. So x, so we're gonna have like x. So negative over negative, that's positive. So we're gonna have like 2. plus square root of 2, or x is 2 minus square root of 2. You divide by 2. You divide the 4 by 2 and the 2 by 2, right? So 2 by 2, of course, it's just 1. 4 by 2, it's 2. Anyway, but as I said, you don't have to simplify. You can just keep it like this. So that's for my x-intercept. So the answer, of course, in the answer, guys, you have to use the point notation. So the x-intercept, that would be, or so it should be like 2 plus square root of 2, 0, and 2 minus square root of 2, 0. And again, don't worry, in the test, you're gonna have a perfect square, so you won't have to deal with this square root. All right, so then the y-intercept, guys, is just Julian. Yeah, well, I know you're already scared from the test, and then you get another square root. That would be like that would be like a nightmare, I guess. Anyway, so in the y-intercept, guys, just evaluate f of 0, right? So just plug in 0 in the function f. So it's like minus 0 squared plus 4 times 0 minus 2. So the answer would be just would be negative 2, right? So my y-intercept would be just negative 2. Of course, x is always 0 in the y-intercept. All right, we got x, y-intercept. The axis of symmetry, well, it's just the same as the equation of the vertex. So for the axis of symmetry, guys, this is a C. So in C, axis of symmetry. So axis of symmetry is just the vertical line passing through the vertex. So the x is minus b over 2a, and we know that. So the answer here, just x equal to minus b over 2a, and so that would be same as the vertex, which is positive 2. So here we're gonna have positive 2. That's the axis of symmetry. Whether f has a maximum or minimum and its coordinates. Well, as I said, like for a parabola, when you have a quadratic function, the vertex, I mean, of course, if the parabola opens up, the vertex is going to be a minimum, and if the parabola opens down, then the vertex is going to be a maximum. So here in this case, this parabola, because a is negative, a is, so f of x, again, it's minus x squared plus 4x plus minus 2, right? So a is negative 1, right? This is your a. Here's your a. This is your a, right? A is negative 1. So if it's negative, we know it opens down. So the parabola opens down, right? And if the parabola opens down, it means that the vertex is going to be a maximum, a global maximum, actually. Okay, because the parabola is going to open down. So, so the answer here should be there is a local maximum. There's a maximum, a global maximum, actually. So the vertex is a global maximum, and that's so again, the vertex was 2, 2, right? That's the point. That's your that's the coordinates of your vertex. It's 2, 2. So, I mean, again, for this quadratic function, the vertex is going to be either a maximum or a minimum, depends if the parabola opens up or down, right? And then finally, use the above information to sketch the graph of f. So let's graph or sketch the graph. The graph. So in the graph, guys, you need to get full credits. You need to plot your So let me just make it clarify this. You need to plot the vertex to get full credits. Plot the x and y intercept. Okay. If you forget to plot the vertex or x y intercept, you won't get full credit. Okay, so it's really important that you plot these points. And so here, like in this case, my vertex is at 2, 2. So I'm gonna need 2, 2. So that's my vertex. 2, 2. So here's my vertex. All right, I need to plot my x-intercepts. So my x-intercepts, as they're not like whole numbers, like just like they are the decimals. Actually, so we have like 2 plus square root of 2, 0, and 2 minus square root of 2, 0. Anyway, so what you can do, I mean, if for some reason, like in the test, you have like this square root, just try to approximate with the calculator. So if you try to approximate like a square root of 2 with the calculator, it will be, I think, 1.7 or something. So this is like 2 plus 1.7. Anyway, so it's somewhere right here. Okay, and 2 minus 1.7 will be like 0.3. So it's let's say somewhere right here. Okay, again, you don't have to, you know, the points, they don't have to be like exactly at the right position. Okay, it's just you know, just some approximation. Okay, so here are my x-intercepts. I have a y-intercept at -2, right? 0, -2. So I'm gonna need -2 here, and that will be my y-intercept right here. Okay. So you start, how will you graph this parabola? You start from the vertex. You always start from the vertex, okay? You start from the vertex and then you go to, well, of course, this parabola opens down, right? So you have to go all the way down. You start from the vertex and you go all the way down. But of course, you have to join your x-intercept. So here's my x-intercept, and I'm gonna go all the way down. And on the other side, the same thing, I'm gonna go all the way down, but I'm gonna join my points here, my x-intercept and my y-intercept. Okay? So again, it opens down because A is negative. A is -1, right? It opens down because A is -1. So that's my f of x. That's the shape of the graph of f. Any question, guys? So again, make sure that you plot your vertex and the x-y intercept. And when you graph, you start from the vertex. If it opens up, you go all the way up. If it opens down, you go all the way down. And make sure that you join your x-intercept and y-intercept. All right. Number 6. Is there any question first? I don't know if. Okay, no questions. No. Number 6, guys. You want me to do A or B? A probably, or B. Number 6. For example, let's do B or A. I mean A or B. It doesn't really matter. But so problem number 6. The B melody. Okay, perfect. So problem number 6. Let's do the B. I mean B or A, they're the same. I mean, this is just right. So in the graph, guys, so it's so it says f composed with f of 1, right? So we have like, so we have f first, and then we have another f, right? So we have f first, we need parentheses, and then another f. So here's my another f of what? Of 1. So I'm gonna put 1 here, f of 1. That's by definition of composition, right? Now, inside the parentheses, it's f of 1, which is, so be careful, guys. I mean, here, there are 2 graphs. So this is the graph of f and the graph of g, right? So you need to check the graph of f. And as you said, I think, Sean, f of 1 is 3.
3.
Yes, very good. So So this is f of 1. There is an f in here outside, so I'm going to keep my f outside. There's parentheses, and inside parentheses now it's going to be 3.
That'll be 5.
Yes, very good. And then f of p, that would be 5. Absolutely. So how I got the 3 guys, just I mean, because I mean, if some of you have a trouble with this, so you are looking for f of 1, for example. So so 1, 2, 3. This is 1 here, and the graph of f, it looks like this here, something like this. This is my graph of f. Okay, just forget about the graph of g. We don't care about g. So f of 1, you start from 1, x equal to 1. This is my x equal to 1. Use vertical line, and then you intersect the graph. So here, when you use this vertical line, it's going to intersect the graph at this point. You see this point, guys? And the height, or the level, or the corresponding y is 3. So that's why f of 1 is 3. Okay. Now, I have to evaluate again, but this time it's f of 3. So you go to, like, here's 3, all right? You go to 3 here, and then you use your vertical line. It's going to intersect the graph at 5, right here, 5. Okay, that's why we got 5 as final answer.
And what about the other one? Because it's kind of a little more.
Yeah, sure. I mean, yeah, sure. The other one,
g of f of 0.
Yeah, f of 0. So we have g first. So I'm gonna put g first, and then parentheses, and then I'm gonna put f of 0. So you start with f of 0, which is from the graph, f of 0 is 2, right? So this is 2. And this is a g outside with the parentheses. So now we have to find g of 2. So now we have to change the graph. So we have to check the graph of g, which is, so g of 2 actually is -5. So g of 2, it's -5. Yeah, thank you, Lorden. So the answer is -5.
All right, that was tricky.
Yeah, kind of tricky. Yeah, I know. Any question, guys, about this? Natalie, you probably, let me see. Someone asked me about this. Mia, okay, perfect. Okay, cool. All right, guys, we are almost done with the review sheet. So there are 2 more problems, 7 and 8. As I said, you just ignore the number, problem number 9. So 7 and 8, it's about, so 7, the inverse, right? Yes, Lisbeth.
Sorry, Professor. For example,
Yes.
because I was checking the graph and we have like 1, and then we have to go all the way up and put it without 3, with 3.
Oh, you are saying why I got why f of 1 is 3?
Uh-huh.
Well, f of 1 is, yes, f of 1 is 3 because, so you start at x equal to 1. This is my x-axis, right? So here, this is my x equal to 1. Okay? And then you take a vertical line passing through 1. So you take this vertical line and intersect the graph at the level y equal to 3, right? This is here, when you intersect the graph, the corresponding y is 3. I mean, the level of the height is equal to 3. The height of this point, it's actually 3. You don't see the point. There's no point in the graph, but still, you have the intersection with the graph, right? You intersect the graph, and that will be your point. You see what I mean, or?
Yes, because I was checking the graph. That's what I was confused by.
Yeah, no, but again, it's just here's 1, here's 3, and the graph is like, you know, like this, something like this, right? So you start from 1 and you use vertical line. It's important to use the vertical line. So here's my vertical line at 1, right? So we have intersection here with the graph at this level. And this level corresponds to y. You see here, it corresponds to y equals to 3. That's why f of 1 is 3. Right? Any other question, guys? Okay, so for number 7, the inverse. Find the inverse. So problem number 7. So we have to find the inverse. So f of x is x minus 3 over 4 plus 5x. Okay, so first step, guys, just replace f of x by y. And then interchange x and y. So y becomes x. And x becomes y. So there's a y here. So this is equal to, so y minus 3 over this y plus 5y. Sorry, 4 plus 5y. All right, so I just, sorry, I just changed, I interchange x and y, right? So x, this x here become y, and the y becomes x. All right, now I have to solve for y. So I guess this is a tricky step. So we have to solve for y. All right, so here, guys, so we need to move all the y's to the top first. There's a line here in the denominator. So I need to move this y to the top. And if you just take the reciprocal, then you're gonna also end up with another with the y in the denominator. So the idea here, guys, is to cross multiply. So first, I mean, on the right side you have a fraction. The left side you can make it look like a fraction. So you can just divide by. If you divide this x by 1, it's still x, right? And now it looks like a fraction. And so next you cross multiply. So I'm just cross multiplying here. And so when you cross multiply, so that's like x multiplied by the 4 plus 5y equal, and the other side would be like 1 times y minus 3. All right, so now all my y's are like in the top, right? There's no y like in the denominator. All right, that's good. Now, next step, guys, you have to distribute, which means you have to get rid of the parentheses, okay? So you just multiply the whole thing. So it's like x times 4. This x times 4, that will be 4x. There's a plus, so here's my plus, and then there's this x times 5y, so it's plus 5xy. That's the left. The right side, 1 times y, of course, just y, and times 1 times negative 3 is it's again negative 3.
You listen here.
Excuse me? Excuse me? I didn't hear your question. Or it was for me the question, or? Okay, I guess I probably not. All right, guys. So now the thing, you want to solve for y. So we have to focus on y, okay? So what we do is, the idea is to move all the y's on one side. So once you move all the y's on one side, on the same side, then y would be like a common factor. So then you can factor out your y, okay? So there's a y in here. There's a y in here, so I have to put the y's on the same side, okay? So for example, if you decide to move this y to the other side, so how can we do that? Well, you just, this is a plus y, so you do the opposite operation, right? You subtract y. So now it's 4x plus 5xy minus y. And on the right side, it's just negative p. It's negative p. Okay. All right, that's good because now on the left side, as you can see, guys, there's I have all my y's on the left side. Here's a y and here's another y. So then y would be a common factor. But the thing is, this is 4x, right? And in this 4x, there is no y. So I cannot really, y wouldn't be a common factor, right? Because there's no y here. So I need to get rid of this 4x, right? So then I can factor out y. So then y would be a common factor. So how do we get rid of this 4x? It's plus 4x. Well, I'm going to just subtract minus 4x. Minus 4x. So that's 5xy now minus y. So this 4x minus 4x, of course, cancel out. And on the right side, it's minus 3 or negative 3 minus 4x. And you see now, guys, because now y is a common factor. Okay. I have y here, here, and here. Okay, so I'm gonna just pull out this y. Okay, so this is, here's my y times. So if you pull out y from the 5xy, then you're left with 5x. Right? Minus, because there's a minus. Now, if you pull out y, so this y, it's like y times 1. Right? Y times 1 is y. So if you factor out the y, then you are left with 1. This one here. So this is why it's minus 1. And on the right side, it's just, again, minus 3 minus 4x. And now, because here it's multiplication, the opposite operation would be division. So we have to divide by, because I want to solve for y, so I have to divide by this 5x minus 1, both sides. And so then, as you can see, this one here cancel out. So now I'm just left with y on the left equal to this minus 3 minus 4x over 5x minus 1. And that's my inverse. That's my inverse function. Answer. So f inverse is this minus 3 minus 4x over 5x minus 1. Okay. Any question, guys?
Professor.
Okay, perfect.
Professor.
All right.
Professor.
Yes. Yes. Oh, yeah, sure. I can screw up. Yeah.
Here's the thing. When you're okay, for the top part, when you're moving a number to the other side, on the right, you always have to move the first number, and on the left, you always got to move the second number.
No, it's not about first number or second number. It's you want to solve for y, right? So the idea is to put all the y's on the same side. So you need to move all the y's on the same side. Because when you move all the y's on the same side, then y would be like a common factor, and so you can factor out y. Okay. Now, if you have something with, excuse me. No, okay. So so that's why I you see here I subtracted this y. So then now on the left side, so now all the y's that are like on the left side. Okay. On the right side, there's nothing here except this minus 3, right? But then again, the idea is to have y as a common factor. But the thing is, this 4x, you see this 4x, because there is no y here. So that will be a problem if I want to factor out y, because there's no y here, right? So the idea would be to get rid of this 4x. And how do we get rid of this 4x? Just it's a plus 4x, just subtract 4x. That's why on the right side, now I have like minus 4x. But again, it's not about no, first number or second number. It's about moving all the y's like on the same side and everything else on the other side, right? You see what I'm saying? Or
Yeah.
no. So it's like, you see, I when I see this equation, I see there's this y here and there's y here, right? So I need to move both in the same side. Now there's this like, there's this 4x and there's this -3, and there's no y here and no y here, right? So I need to move them on the other side. Any other question, guys?
You said that we're not doing point number 9, right? That's not going to into the
No,
exam.
no. It's not in the test. No.
Alright.
Okay, so let me then, if there are no questions, then I'm gonna finish with number 8. All right, number 8, compute and simplify. This F composed with G, etc. So I guess anyway, I have to stop like probably at 7:55 because I have to, I have to.
I'm gonna be honest, I don't mind taking it right now.
Well, because I have to upload the test. Yeah. Okay. Let me just finish with this last number, and then I'm gonna let you go, guys. Okay. You already okay? Cool. Okay. Let me just finish with this one, number 8. Let me just do one of the composition. So like f of x. This is 3 minus 2x over x plus 1. And there's this g of x, 2 over x plus 1. All right, so we want to compute, let's say, f of g of x. So f of g of x. So I'm going to just show you guys, like, when we have fractions, because I know some of you have trouble with the fractions. So here, I have to substitute this x with this g of x. So there's an x in here, x in the denominator. So I have to substitute both by g, right? So this is like 3 minus 2 times g, so times g, over, and x, there's an x in the denominator. So that will be g of x and plus 1. All right, so then this would be equal to 3 minus 2 times g, so g is 2 over x plus 1 over, and then again g, 2 over x plus 1, and then there's plus 1 here. All right, so my advice for you guys, whenever you have a fraction and you multiply the fraction by, or you add, you multiply the fraction by a whole number, or you add a whole number to a fraction, my advice for you is just to make the whole numbers look like a fraction. So like this 2 here, that would be like 2 over 1, or like 1 here, that would be like 1 over 1. Okay, just divide by 1, and that would be a fraction. Or this 3, this is just a 3 over 1, for example. Anyway, so like here in the top, this is a multiplication, right? This is times, minus. So I mean, from this rule, so we have to do multiplication first. So we multiply straight across here, right? So this is like, so now it's like 3 times, or 3 over 1 minus, so 2 times 2 is 4, and denominator is just x plus 1 times 1. Now, in the denominator here, as you can see, guys, because it's the sum of 2 fractions, then you need the common denominator, and you just you just like cross multiply. So it's like, this is here times the x plus 1, right? This x plus 1 here, x plus 1 here. Okay, so so in the denominator we are gonna have like 2 over x plus 1 plus x plus 1 plus over x plus 1. Okay, now let's continue with the top. The top, the same thing. We need the common denominator. So it's the same thing. You you multiply here the top and the bottom by the x plus 1. So this is like 3 times x plus 1 over x plus 1 minus 4 over x plus 1. And in the denominator is like 2 over x plus 1 plus x plus 1 over x plus 1. All right, so now we, so once we have a common denominators, so we have a common denominator here, and we have a common denominator here, so we can just add the top and the top of the fractions. So it's gonna be like 3 times x plus 1 minus 4 over my common denominator, which is x plus 1, and in the bottom, it's 2 plus the x plus 1 over my common denominator, which is x plus 1. Right? And now, now it's division of fractions, of 2 fractions. So you flip the 1 here, denominator. So now it's like, oops. So it's like 3 times x plus 1 minus 4 over x plus 1 times, and you flip the denominator. So that's x plus 1 over 2 plus x plus 1. Right. Well, because it's a multiplication here, so this x plus 1 cancel out with this one here. And now, yes, Lisbeth.
Professor, I have a question in that part. For example,
Yes.
now let me see. In x plus 1, and then you put 2 plus s plus 1.
That's x plus 3.
You move, for example, you move the one that you have in the purple circle, and you put it on the top, and then you take the sign like 2 plus therefore 1 that is on the top of the circle, of the purple circle. For example,
I mean, what I did,
x plus 1, right?
like here in the numerator, this should be like x plus 3 first, right? But anyway, so what I did here, I just, you have to flip, because when you divide 2 fractions, you have to flip the denominator. So that's why I flipped this, the denominator. So it's that's why I got this x plus 1 in the top. So that's why I got this x plus 1 in the top and this x plus 3, because I flipped the denominator. Whenever you divide fractions, you flip the denominator.
Thank you.
And all right, so here this is like 3 times x plus 1 minus 4, and here it's like 2 plus x plus 1, and of course we can simplify this. So the top will be like 3 times x plus 3 times 1 minus 4, and then the denominator is it's actually x plus 3, and then it's 3x, 3 minus 4, it's minus 1, so it's 3x minus 1 over x plus 3. Okay, so that will be the answer. So don't forget the common denominator, guys. Whenever you have fractions, sum or subtraction, or subtraction of fractions, you need the common denominator. If you don't do the common denominator, then for sure the answer is incorrect. Yes,
Okay.
Lisbeth. Yes.
For example, you move 3x plus 3 minus 4.
Yes.
It's because, for example, in the first one that you have 3x in parentheses x plus 1 minus 4. You sum that one. For example, 1.
Yeah, because 4
minus 1.
Yeah, because parentheses, it's a PEMDAS rule. So first we have to do so there's a parentheses, but then you have to do multiplication before the subtraction. That's why that's why I did the multiplication. That's why I multiplied by 3 first, the x plus 1. right? Because it's, PEMDAS rule. First, you have the parentheses, exponent, and then you have a multiplication. So multiplication comes before the subtraction. So you have to multiply first, and then you subtract the 4, or you take away 4. But first, you have to multiply by 3. You have to multiply this x plus 1 by 3. And you have to multiply the whole x plus 1 because x plus 1 is between the parentheses. Okay. Is there any other question, guys? I don't. Let me check the chat. Yeah, sure. Oh, we have some more time. You are ready, guys. Okay, cool. Okay, so I guess there are no questions, guys. All right. So as I said, the test, you're gonna have 8 problems. 8 problems in the test. No surprise. If you know how to do the review sheet, you know how to do your homeworks, then you should be fine. You don't have to, you don't have to worry about the test. Okay, if you know how to solve the problems in the review sheet and homeworks, then you should be fine for sure. Okay. All right, guys. What? I missed something in the chat, I guess. Oh, yeah, sure. My pleasure. I mean, that's my job, Lorden. Yeah, sure. Yeah, sure. Yeah. Thank you. Thank you, Lorden. Thank you, Tiffany. That's my job. All right, guys. Well, I'm going to stop recording, I guess, because, well, I mean, I guess we're going to stop here.